Hello, everyone. I'm Arcadius, and today it's my pleasure to join Dr. James G. Lennox for a discussion of Aristotle and his ideas on the scientific method. Hello, Doctor.
Hello, Arcadius.
Dr. James G. Lennox is an esteemed emeritus professor in the Department of History and Philosophy of Science at the University of Pittsburgh. He is renowned for his work on Aristotle, especially Aristotle's biology and philosophy of biology. His current research interests include ancient Greek philosophy and science, William Harvey, Charles Darwin, Darwinism, philosophy of biology, scientific inquiry, and explanation in historical context. I think if there is anything you want to add, you're welcome to do so. I think we've got the essentials.
Only that I've also done a fair amount of scholarship related to Ayn Rand and objectivism, including being the editor or co-editor of a series published by the University of Pittsburgh Press, known as the Ayn Rand Society Philosophical Studies series.
Yes. And today, our main topic of discussion is basically your latest book, Aristotle on Inquiry. And it deals with Aristotle's scientific method and his view of inquiry. And my idea for today's interview is to go a little bit chronologically through issues that arise throughout the book, and go through some great snippets of it. So one of the starting points, I think, of your book is that many think that Aristotle has a rather poor and not much detailed account of norms and the process of scientific inquiry. You, on the other hand, say that people have been looking for such norms in the wrong places. Could you expand on that?
Yeah, I suppose the way to think about this, I know there's a question you want to ask me later about the concept of an erotetic framework, which is appears in the subtitle of the book that you're talking about, that one. And my overall theme of the book is that Aristotle has, in the second book of the Posterior Analytics, a framework for the pursuit of knowledge or inquiry. It's quite detailed, it's quite interesting, but it's also very abstract. And if you try to derive from it more than Aristotle intends to provide there, then you will reach the conclusion that many people have reached, that he has very little to say about induction, even though he claims that induction is the basis of scientific knowledge and the basis of the principles of scientific knowledge. It's very strange for him to make such a grand claim about induction and then say very little about how it actually works. What I argue is that the posterior analytics is laying out a framework of questions and answers. Erotao is the Greek word for to ask questions or to question. And erotetic was used in the 1960s through 1980s by a subset of people in logic and the philosophy of science to refer to what they saw as a distinct kind of grammar, syntax, and semantics related to asking and answering questions. And they felt that the logical techniques that were focused on esoteric propositions, just propositions that assert or deny something, which is the way most logic is understood, didn't capture the way in which this language of asking questions and answering questions was, it kind of fizzled out. And I have an explanation for why that happened. The last work that really made use of this way of thinking was Bas van Frossen's The Scientific Image. He has an entire chapter that's focused on understanding science in terms of answering specific kinds of questions. At any rate, that framework is very important. It's a framework that tells you that you have to determine whether something exists before you go on to explore what it is, and so on. And that you have to establish certain facts before you go on to ask questions about how to explain those facts. And Aristotle also has fascinating things to say about how those two pairs of inquiries are interconnected with one another. And it turns out they're very tightly and closely connected. And if you go through his works, that framework is always in place, not just in natural science. If you look at the ethics, a friend of mine, Joe Karbowski, has written a book recently on Aristotle's methods of inquiry in the Nicomachean and Eudemian ethics, and actually employs the framework that I've suggested and says it's operative there as well. So it's not just scientific method, as we might understand that. If your goal is knowledge in whatever domain at all, what you read about in the second book of the Posterior Analytics is quite valuable. But where it doesn't help you is in understanding how it is, the processes by which you move from having first of all, establishing factual information at a level and nature that's appropriate for scientific investigation and explanation. And he also says very little about the processes by which you get from that stage to the discovery of causes and essences that explain the things that you want to explain. I argue that that's intentional, that he thinks that the norms that govern those steps in science are domain specific. If you're doing astronomy, certain kinds of methods of inquiry in the search for causal understanding are appropriate. Those methods are completely inappropriate if you're studying embryology, or if you're studying botany, or if you're studying mathematics. So his thinking is that the norms that govern those processes aimed at discovering causes and the natures of things, are domain specific. And if you want to understand those, you have to look at the introductions to the specific treatises that are written to offer you accounts of those different domains. So that's the basic strategy.
As I understand it, Aristotle's picture of science in his insistence on domain-specific norms runs a bit to the contrary to how many people think of how science works. We often hear of there being the scientific method, which is very often summarized as you have to have a hypothesis, deduce consequences, and then check those or falsify. There are different versions.
To which I say, how did you get that hypothesis?
Exactly. But speaking generally, do you think that this domain-specific approach could somehow inform fruitfully today's philosophy of science?
Yes, and not just philosophy of science. I think epistemology needs to have a lot more to say about inquiry. The only 20th century philosopher of science that actually did very much work in that direction at all was Susan Hack. She actually wrote a book where she was arguing explicitly for an epistemology of inquiry. I could go into the reason why that was verboten in the 20th century. It has to do with certain views about the nature of science that come out of the logical positivist, logical empiricist tradition. It has to do with something I know you might want to talk about later as well, distinction between discovery and justification. Fortunately, I think a lot of what's going on currently in philosophy of science and epistemology is much more friendly to that idea. There's a lot of research going on right now about the nature of concept formation, the role of concepts in scientific discovery, and I think that's very good news. John Norton's The Material Theory of Induction, my colleague in HPS in Pittsburgh, has something similar to say. Contemporary science, as opposed to philosophy of science. He says, turn your eyes away from the idea of a general logic of induction and think about what he calls the material induction. That is induction that's grounded in the facts in specific domains. I think that's great. Where I perhaps disagree with him, although I haven't read his recent book, so the disagreement may have faded away, is that I think you do need what you get in the posterior analytics as well. And that is very general, very abstract. It's intended to apply to any domain where the goal of your inquiry is knowledge. And I think what you get in each domain for Aristotle is something like a specific application of the ideas in the analytics that, however, do require experience in the domain that you're exploring. Not sure that completely answered your question. So if it didn't, ask a follow-up.
It does answer it to some degree. Maybe I can wrap this up with some mention that I think it would be very useful for scientists to think whether they are not applying norms that are appropriate to other domains but may not be so well suited to their domains. And of course, one of the prime examples could be how methods of physics were attempted to be applied to psychology in the 20th century. This has gone away to a little bit, but in general, that's I think very fruitful approach to try to avoid that which Aristotle, as you explain, recommends to avoid.
Yeah, I mean, Aristotle says the same kind of thing about his predecessors in two different respects that I do talk about in Norms of Inquiry. First of all, the materialists, Democritus, Empedocles, Anaxagoras, want to have a sort of one method fits all approach, that the only things we really have knowledge of are eternal, changeless material things and their interactions, whether it be atoms or whether it be basic elements. And if they study animals, which they clearly do, because Aristotle criticizes their views about all kinds of things having to do with animals, they make the mistake of trying to explain everything by the methods that are appropriate for interactions between hot things and cold things and wet things and dry things, or between atoms of different shapes and so on. At the other extreme are the Pythagoreans and the Pythagoreanizing Platonists who want to explain everything in terms of mathematics. And at one point in the Nicomachean Ethics, he's making a point about domain-specific methodologies. And he says it would be as inappropriate a rhetorician or mathematical demonstration as it would be to demand of a mathematician only that he give persuasive rhetorical arguments. So he's very much on board with that very, very line of thought.
Let's move to more of the specifics. You cover various interpretations of how Aristotle's approach to scientific method looks like. And among those are interpretations that stress a bit of some rationalist aspects. They try to ascribe to Aristotle some rationalist aspects. And there has been, to my knowledge, at least a debate whether Aristotle is an empiricist even. So my question would be, what role does perceptual knowledge, experience play in Aristotle's account of science?
Yeah. Yes, that's really important. One of the sort of towering names in the field of ancient philosophy in my generation, Michael Freda, was famous for arguing that Aristotle was an arch rationalist, very much in the vein of Platonism. And other people have been persuaded by that argument. The idea, I think, well, first of all, let me back up. Aristotle, over and over again, in the Analytics and elsewhere, says that all knowledge begins with perception of particular things. And in certain texts, especially the first chapter of the Metaphysics and the last chapter of the Posterior Analytics, he gives a story about how this goes, psychologically, if you like. All animals, qua animals, perceive. Some only with the sense of touch, some with more senses than that. Some, but not all animals, can retain those perceptions in memory. Of those animals, some of them can make comparatives, judgments about the things retained in memory. And a subset of those are human beings who start by simply making comparative judgments of similarity and difference. He talks about the empiricoi physicians who, perhaps by trial and error, who knows, try something on a sick person and it works. Somebody comes to them the next day with similar symptoms. It worked that time. This person is similar to that person. I'll try the same thing on this person. And he says physicians that have been trained that way are superior to physicians who just do book study and know the theory of medicine, but have never actually touched a patient. But the best person, he says, the best doctor is one who has that empirical knowledge, uses it to form judgments about kinds of things, forms concepts, and at some point discovers that there's a causal relationship of some kind between the medicine that this kind of disease needs and the symptoms of that disease. So it's very clear psychologically that he thinks that's how things go. Now, the question is, for a 20th century epistemologist, well, yes, we know that that's psychologically how things go, but how do you ground or justify your claim that you've gotten knowledge by that? And I think heavily influenced by people like Wilfrid Sellars and Donald Davidson, they argue that that kind of justification has to take place, as they put it, within the space of reasons. The story about perception, memory, comparative judgment, etc., is a causal story about what goes on in us causally. But that doesn't give us any grounds for claims that what we've arrived at the end of such a process is knowledge. That has to come by some kind of rational method. And they're imposing that way of thinking, I think, on Aristotle. And there are texts that, if you already think that that's the right way to think, and you're reading Aristotle sympathetically, you'll read those texts in a way that fits with that story. I don't think they have to be read that way, but there are texts that can be read that way if you're already committed to that way of understanding epistemology. So I think that's what's going on. My own view is that Aristotle, in the Posterior Analytics, devotes the first book to spelling out very clearly what the goal of scientific inquiry is. This is what scientific knowledge, unqualified scientific knowledge, looks like, right here. And so you start book 2, which says there are as many forms of inquiry as there are kinds of knowledge, already knowing what it is you're pursuing, what you're going after. Now the question is, how do you start with experience and perception and get to that goal? But if you already know what the goal is, this is why I think the epistemology inquiry is so important. If you already know what the goal is, that already puts certain constraints on the process of inquiry. And it also gives you sort of checks on whether you're staying on the right track or not. So I think there's a kind of justificatory process that goes on all the way through the inquiry process. It's not something that, okay, there's this causal process that goes on and we end up with beliefs. And then there's this completely other thing that happens at some point after that, where you say, okay, I've got this belief, but is it knowledge? First of all, I don't think that kind of bifurcation between belief and knowledge is in Aristotle. He refers to perception, the perceptual acquaintance with particular things, as a kind of knowledge. What's important is figuring out how you get from that kind of knowledge to a much more robust kind of knowledge. And I think the real challenge for an epistemologist thinking about Aristotle is it seems counterintuitive, and this may be part of what's going on as well. It sounds counterintuitive to start with a weak form of knowledge and claim that that's the grounding and basis for a much more robust kind of knowledge. It's like resting the foundation on a very tiny, pin.
Yeah.
So there needs to be, a lot more said about that. But that's in broad strokes. That's the way I see things.
Here we have briefly mentioned the distinction of modern philosophy of science between the context of discovery, the context of discovering an idea, and then justifying this idea. So here Aristotle again runs against modern philosophy of science, though from what I know, at least since the 80s, that distinction has been contested heavily.
Yeah.
Think aside Thomas Kuhn's Structure of Scientific Revolutions, where he also criticized this distinction, but there has been a lot of research on the process of discovery.
Yes.
The neglect has been happened before, has been repaired to some degree. That's for those listening, so they have a bit of an updated picture of how philosophy of science looks like today.
Yeah, you're absolutely right. And a lot of work on causal discovery as well, in particular, which is more in the 21st century, but certainly starting in the 20th. And the funny thing is, that's always been the case. I mean, it's really the anomaly is the first 50 years or 60 years of the 20th century. If you go back to the 19th century and you look at John Herschel or William Whewell or John Stuart Mill, they were all talking about the processes by which you discover causes. And if you go, they were all influenced by Francis Bacon. And if you go back to Francis Bacon, he was also very much about the processes by which you go about making discovering the natures and causes of things. So it's really the anomaly in the history of philosophy is that period from 1900 to 1960.
You also mentioned that Aristotle informs his discovery of the norms for science by reference to the goal of science. And that goal, as you write in your book, is episteme. It's that advanced causal understanding of how the world looks like. And those lower levels are techne, it's the art, it's practical knowledge of how things work. And there also is experience, which as far as I understand, it's kind of associative knowledge of how things are connected in the world.
Yeah, the sort of thing that I mentioned about the doctors having in the beginning of Aristotle's metaphysics.
Do you think there are some parallels today in how scientists work and those medical scientists that Aristotle speaks about here?
Yes and no. Techne for Aristotle, sometimes it's translated art, sometimes craft, is not an earlier stage of episteme. It's a parallel kind of thing. Episteme is knowledge pursued for its own sake, not pursued for the sake of determining how to act or how to build or make something. Techne is the name for things like medicine, house building, even rhetoric, things where there are norms governing the activity, but the goal is producing something. In rhetoric, it's producing a certain kind of effect in the audience. In house building, it's creating a house. In medicine, it's producing health in a patient, and so on. And also what we would consider art, tragedy, for example, how the proper methods to go about producing a tragedy, which Aristotle talks about in his Poetics. Poesis, which means making or producing, actually, in Greek. So in the passage I mentioned earlier at the beginning of the Metaphysics, his example of acquiring causal knowledge is actually medicine. So you can have medicine that's this solely experience-based sort of thing. And I should mention that apparently either during Aristotle's lifetime or shortly afterwards, a debate begins to take place, which ramifies through the whole history of philosophy, between certain people defending an empirical approach to medicine and certain people, logikos, defending a rationalist approach to medicine. And the distinction was basically whether medicine should stop with just that kind of associative, I tried this medicine on these symptoms, it worked. If I see similar symptoms, I use similar medicines, and so on. Or should they be involved, as the doctors, probably influenced by Aristotle in Alexandria in the years after Aristotle's death, were in using dissection and maybe vivisection to determine how the body works and to actually study how different medicines affect the different organs. And when somebody is showing certain symptoms, is it because there's something wrong with the liver or something wrong with the heart? So pursuing a kind of causal understanding of what's going on. And that debate, the empirical versus rational debate, reemerges, but as the distinction between the rationalists and the empiricists in the 16th century in Europe, and to some extent has influenced the history of philosophy from that point on. Aristotle thinks that you can get causal understanding in the technes just as much as you can in the theoretical sciences. So in that respect, I think the only difference between then and now, so to speak, is that we're very comfortable thinking that even the most abstract theoretical knowledge is going to be useful for something. And we can thank Francis Bacon more than anyone else, I think, for that idea that scientific knowledge is useful, is valuable, can be put to use in the world. And of course, in our time frame, the distance between theoretical discovery and putting that discovery into practice is becoming narrower and narrower and narrower. I mean, what we can do with the knowledge that geneticists acquired only 20 years ago in terms of medical production and so on is really remarkable. And you could, that's taking place all over the place. I think Aristotle just couldn't imagine that that lack of distance between theoretical understanding and practical application could happen. The distinction that Aristotle makes between episteme, which is pursued for its own sake, and techne, which is knowledge pursued in order to produce something, is a distinction that's much less natural to us, I think, than it was in the 4th century BC in ancient Greece, because we're comfortable with the idea that very abstract scientific knowledge is going to have productive practical payoffs more and more quickly as history goes on. And knowledge pursued for its own sake now probably has a kind of bad name. It's, oh yeah, well, okay, metaphysics, go ahead and talk about metaphysics all you like, but it's really not going to have any practical impact on anybody. Um, I don't believe that, but I think it has serious practical impact on people. But I think that's the only area. If you're talking about scientific knowledge, I think most people today would expect that even the most abstruse, abstract scientific knowledge would have payoffs of one kind or another. Think of
Let's
the
now,
way particle physics has an impact on computers, for example.
yes, and how researched into what back in the day would be called physics, namely what's actually at the level of, let's say, subatomic particles, is very often called philosophy today, which wouldn't be called philosophy not so long ago, uh, but is dismissed as kind of abstract, not practical philosophical inquiry. Let's now go into some specific norms that Aristotle recommends for scientific inquiry. You speak about how Aristotle gives a norm for how can we know that we have arrived and grasped a commensurately universal proposition. And I think it would be good to review that, especially as people think that Aristotle doesn't have much to say about how induction works.
Yeah, good. Yes, the posterior analytics actually does have quite a bit to say about that, I think. So there's one area where I think it's much richer than is typically understood. First of all, let's get our terms right. Commensurately universal proposition or coexist is a proposition where the subject and the predicate are, to use extensional language, coextensive. Um, uh, all and only things of this kind have this property. So to give a couple of examples, all and only triangles among plane figures have interior angles equal to two right angles. It's an example Aristotle uses over and over and over again. One that he uses later in book 2 is he's imagining a process of scientific inquiry where the inquirer gets to the point where he sees something in common to all the trees that lose their leaves in the autumn, as we would say. And it doesn't matter whether this is actually a commensurate universal or not. Aristotle's only using it as an example, but he says they're all broad-leafed. And he doesn't give us much by way of information about how you might reach that, but he gives us enough information that you can sort of fill in the blank spaces. He mentions that in these kinds of cases, where you will start is seeing that something that has that property has the other property. So if you're in a vineyard, you'll see that grapevines have this property that they are both broad-leafed and they lose their leaves. But Aristotle says, even though that's in a sense a universal proposition, all grapevines lose their leaves. He says it's not coextensive because leaf loss extends beyond the kind. But he says, but not beyond the genus. So he's telling you that there's some higher level kind for which this property is coextensive. I sometimes tell a sort of story about two children, one of whom parents raise grapes, the other one raises figs. the one child growing up on the vineyard formulates that first semi-universal proposition, namely that all grapevines lose their leaves in the fall. And the other one, growing up on a fig farm, formulates exactly the same proposition except about figs. And then they start visiting each other and they realize, oh, your trees do that too. Oh, your vines do that too. So they realize that this isn't just a property of this kind of tree or this kind of plant or that kind of plant. And then they ask themselves, I wonder what other kinds there might be that have this property. And they start looking at other broadleaf things to see whether they also lose their leaves in the fall. And then, and you'll notice this is a Baconian compare and contrast kind of process that's going on here. Then they'll say, okay, but are there trees where this doesn't happen? And they notice cedar trees, and they notice pine trees, and they see that this doesn't happen. So they say, all right, well, what's in common to the ones that do lose their leaves that isn't shared by the ones that don't? Oh, they're all broadleaf. Okay, so you get to the point where you are reasonably confident that all broadleaf plants lose their leaves per se. That's the kind that loses its leaves in the fall. So far, it's a kind of what I call a pincer movement. You start by comparing the things that do with other things to see whether there are things that have the one property but don't have the other property. You can do the same thing with the geometric example that I mentioned. I won't go through it. The last 5 chapters actually, of the posterior analytics, except for 19, the famous 219, are laying out examples of how this works. The one thing that they don't tell you is how you make the final move. All right, I now know that this is the commensurately universal relationship. To really have scientific knowledge in this field, I have to know why all and only broadleaf trees are the trees that lose their leaves. So I've established the fact at the right level for proper scientific demonstration, but I don't yet know why that happens. And Aristotle even says there's a kind of quasi-explanation that helps you in this process. Because once you've realized that all the broadleaf plants lose their leaves, then you can offer this explanation, which Aristotle doesn't think is a real demonstration, but it's an explanation of sorts. Why do grapevines lose their leaves? Because they're broad-leafed. Well, that looks like a causal explanation. But there's, of course, another question. But Dad, why do all broadleaf plants lose their leaves? Right? This is Aristotle, I think, is best understood as seeing scientific inquiry as norm-guided curiosity. It's the kind of thing all children do by asking why about everything. But they tend to do it willy-nilly without much in the way of guidance. So he's trying to lay out some guidance for this curiosity-based process. I don't think Aristotle has much to say about that in the posterior analytics. He stops short in almost every case of giving you any hint as to how that process of getting to the causal understanding goes. But I don't think, and this goes to a question that I think you wanted to ask me at some point, I don't think the proper word for the next step is insight. And I don't think that nous his word for reason or mind or intellect, different kinds of translations for it. I don't think it's some sort of intuitive spotlight that all of a sudden sees the truth. He does have a chapter that I mentioned to you, the last chapter of book 1 of the Posterior Analytics, chapter 34. It's very brief, it's only 12, 15 lines, something like that. But it discusses something that he calls agenoia. It's usually translated quickness of wit or something like that. But I don't think he's there describing some kind of special insight that special people have that the rest of us don't have. I think what he's describing is people who, as he puts it, can hit on the cause quickly. And he gives an example of people who instantly figure out that the reason why the side of the moon that's always illuminated is the side that faces the sun is, well, because that's where it gets its light. It actually doesn't shed its own light, it gets its light by reflection from the sun. Now, notice, actually, you actually need a whole lot of theoretical knowledge to even ask that question, but we won't go into that. So I think he's got this idea that there are certain people who have rather automatized processes like the process that I could describe about how you actually get to the knowledge. I gave you an example in an email. If you like, I can review that example for your audience. Aristotle gives the answer in the Analytics, but he doesn't tell you how he got it. He gives you the answer that broadleaf trees lose their leaves because they have that little stem that connects the leaf to the branch. And they get their nourishment, he thinks, by fluid going from the branch through the stem to the leaf. Okay, well, what happens in the fall besides trees losing their leaves? Well, the days are getting shorter. There's less and less light. It's getting colder. So the answer he gives, whether he actually believes it or not, I don't know, is that the fluid that feeds the leaf its nourishment solidifies at that juncture where the leaf is attached to the branch. And the leaf is no longer getting its nourishment anymore, so it essentially dies. That's the theory. And I think it's not hard to imagine how somebody would arrive at that theory just by a process of reasoning. It doesn't take any kind of, aha, but it may look that way if some people do that kind of reasoning almost without thought. I have a friend who worked at Intel for a good part of his life. At one point, I asked that friend if he could help my daughter with the leap from arithmetic to algebra because she was having a little bit of trouble with that move. And he said no, which wasn't like him because he's a very helpful guy. And I said, what do you mean? He said, I never made that leap. I don't know how you do that. He said, I thought algebraically all along. So I don't know how to teach anybody that because I don't know how it happens. That was just automatized for him, whereas it's a struggle for my daughter, and it's a struggle for a lot of people. I think the same thing can go on in all kinds of different domains, and I think that's what Aristotle has in mind when he's talking about quickness of wit, is people that sort of can make that kind of move almost as if they're not reasoning at all.
I think I get it, and maybe we'll come back to it. Now I wanted to touch upon some things of a more popular interest. Speaking in terms of, for example, norms for biology,
yeah,
Aristotle stresses the importance of putting priority on final causes, on the end results of processes for which various causes and other processes are means.
Yeah.
How consistent is that thinking with modern biology and especially Darwin's thinking?
Right. Good. So to review Aristotle's view briefly, the language of final cause is language introduced in Latin. I think not before the early Middle Ages. Very prominent in the Renaissance and all the way through till the end of the 19th century, which will be relevant in a moment. Aristotle's word it's actually a phrase that he turns into a term, basically. That for the sake of which. So what he wants to claim is that, well, say you're looking at biological development, embryological development. Ordinarily, when you have a egg fertilized by a sperm, that's not Aristotle's view, but it's analogous to Aristotle's view. A process unfolds that is very complicated, stretches over a very long period of time, starts with a drop of fluid that is completely non-diversified. And through the process of development, all these different organs develop in different places at different times, in different relationships to one another. And lo and behold, what happens at the end of the process is you have an organism that looks like a small version of the parents. Pure accident, Aristotle says? No, the process was directed toward that goal right from the start. Now, you could say that nevertheless, the process wasn't directed at that goal in the sense that the goal was sort of drawing it forward. After all, you could have the same story that we have today, that there's a genetic program. Once the process of development begins, the genetic program unfolds. And the genetic program determines that this happens and then that happens and then et cetera, et cetera, et cetera. And you end up with something that was programmed right from the start. So why not just tell it that way? Why give any priority to the end? And Aristotle's views there are quite complex, but what he wants to argue is that there is something in the process that, what's the right way to put this? That must be directed toward that end in order for it to happen as consistently and regularly as it does. So my friend and former colleague, Alan Godhealth, refers to the capacity at the beginning of the process that is sort of akin to a genetic program, is for the form. And that's why Aristotle calls it that for the sake of which. So he's not claiming that the end is causally an efficient cause. It's not drawing the thing towards it because it doesn't even exist and may never exist. I mean, the process might fail. What Aristotle is claiming is that the causal basis of the process is directed on that end. And in that sense, what the process is defined by reference to the outcome, by reference to the end. So he's not claiming that anything supernatural is happening. He is claiming that there's a power or capacity that's distinctive of organisms that directs that process. So that's one context in which he claims these teleological explanations operate. The other context is he says if you want to understand something like a heart or an eye or a liver or a finger, the most important thing you have to ask is, what is it for? What is its function? That's the reason why it exists, he says. So the eye is for the sake of seeing. The reason why visual organisms have eyes is in order that, or for the sake of seeing. The reason they have a heart in Aristotle is incredibly complex, which I won't go into, but you would tell the same story about the heart. It's there for a purpose. It's there for a reason. That's why it's there. So you can tell a story about the materials it's made out of. You can tell a story about the various actions of heating and cooling and development that produce the heart. But the more important question about biological structures and organs is, what is its function? What is it for? Okay, now on to the Darwinian context. One way of thinking about Aristotle in sort of anachronistic modern terms is he's really focused on adaptation. He's really focused on the question of what things are for in that sense. So is Darwin, very much so. In The Origin of Species, he's regularly using phrases like, natural selection can only act for the good of each being. Act for the good, he says, of natural selection. You can tell stories about him not really meaning that and so on, and lots of Darwinians have. My view is, and this is more based on the work that he does after The Origin of Species is published in 1859. He turns his attention to botany, and he does many, many treatises that he publishes on fertilization in orchids, on the mechanisms for plants that climb, doing their climbing, like vines and so on, all kinds of books like that. And in those books, he's constantly saying that what I'm trying to figure out is the end for the sake of which this plant has this structure in this way. And he uses the word final cause regularly in these works. Now, you might have thought, well, he's just being careless. He's not thinking about the language he's using. But you go back to his notebooks that he was keeping right after the Beagle voyage, notebooks that eventually produced the theory of natural selection. And there's a small notebook where, after he's hit on the theory, he starts comparing a natural selection explanation for an exquisite adaptation with a natural theology explanation. He's got a particular book in mind that he's comparing his ideas with. And in the midst of that notebook, he says, is it or is it not appropriate for me to talk about the ends and goals for the sake of which these things are being structured? And he makes a note, say, I should think about that. So we know this is something he's been thinking about all along. He's realizing that natural selection will offer an explanation for things that the natural theologians thought was the best explanation that could prove God's purpose in the world. So he knows that he's got a different approach to that. And we know he's thinking about that question. Okay, fast forward to 1872, after he's written a number of these botanical treatises. One of his best friends in the United States, Asa Gray, is both a botanist and a natural theologian. And he is asked by the magazine Nature, which still exists to this day, to write an appreciation for Darwin. And he does. And he writes in that appreciation that Darwin should be praised for bringing teleology back into biology, so that we no longer have to make a choice between morphology or teleology, because Aristotle has, or Darwin has wedded the two. Now, Darwin could have either ignored that, or he could have written back to Asa Gray and said, you didn't quite get it. I'm not talking about teleology. Instead, he wrote to Gray almost immediately and said, thank you so much for your kind eulogistic words. I especially like what you said about teleology. I think you're dead right about that, and nobody has noticed it. You're the one to hit the nail on the head, he says. So not only is he using this language, he's been thinking about it his whole life. And by the time he's working on these botanical works, he's made his decision. Yeah, I'm a teleologist, by golly. And when Asa Gray praises him for that, he says, you got it, you're right. So in 1993, I wrote a paper called Darwin Was a Teleologist. And there was a prominent Darwinian on the board of the journal that eventually published that paper, who had been arguing for years that Darwin was the person who put the nail in the coffin of teleology. He killed it dead. And I had just outed Darwin as a teleologist in this paper. And this infuriated him. He actually threatened to resign from the board of the journal that he was actually on. So the way it eventually unfolded, thanks to my recently departed friend Michael Gieselin, or Michael Ruse being very thoughtful about this, was that he was permitted to write a reply to my defense of Darwin as a teleologist, but I was allowed to write a response to his reply, which I did. So that's my view. Now, how does that compare with Aristotle? I think people had trouble understanding Darwin as a teleologist because in the 19th century, and really through most of the 20th century, if you talked about teleology, there was really only sort of two options. If you believe in teleology, you either believe in a vital force in organisms that's kind of quasi-conscious, that can't be reduced to any kind of material forces, or you believe in divine design. You're a natural theologian. You think that organisms have things adapted the way they are because somehow this was God's design for them, having these adaptations. Clearly, Darwin wasn't either of those. So in this paper I wrote, I pointed out, this is not a discovery of mine, but of John Beatty's, that if you look at the people in the 19th century around Darwin, there were four different responses. He is a teleologist. That's a good thing. He's not a teleologist. That's a good thing. He is a teleologist. That's a bad thing. He isn't a teleologist. That's a bad thing. I think what actually happened was that Darwin had hit on what, starting in the 1960s, people started calling selection teleology or consequence teleology. You find this in the works of Harry Binswanger, of blanking on the name of the other eye. I'll come back to that. Anyway, there's a whole group of people who started defending teleological explanation, but arguing that it was based now on our understanding of natural selection. Now, I can tell you how I see that working, and it's fairly robust. If you ask how selection operates, there's a population of organisms. They have a lot of genetically based variation. And those organisms that pass on their variations to the next generation are those that have adaptations that are variations that are slightly better adapted to their environment than the other variations in the population. Well, that means that selection is, in a sense, value consequence oriented. Those organisms that get selected are those organisms that have the more valuable, more advantageous variations in the population. So, in a very real sense, it's the having of those more valuable variations that's a key causal factor in which organisms get selected or are selectively preferred. To me, that's not radically different from the Aristotelian approach. It is different because now we have that underlying mechanism of natural selection, but that underlying mechanism of natural selection does select based on value variation in the populations. And of course, that also allows for evolutionary change. That was a long answer, sorry.
That was an extensive answer, but it was a good one. Another maybe one of the last things is concerning another confusion about Aristotle. I think others have heard many times that Aristotle somehow forbade use of mathematics in various natural sciences, and that's somehow why he's responsible for lack of the development of science during medieval and the Dark Ages. So here's a question for you: whether this account is true?
No. Would you like me to say more?
I'll be very pleased.
Yeah, I actually wrote a paper about this as well back in the 1980s, arguing that all of the sciences that were developing mathematical techniques in the Renaissance and 17th century were already mathematical sciences in the ancient world, and Aristotle was well aware of that and had an account of it. There's only one text in which he actually himself uses mathematics in the natural scientific context, and that's book 3 of the Meteorology. He gives an account of a number of meteorological phenomena, rainbows and halos around the moon, that make use of geometric optics. But even before Aristotle, Plato in the Republic also mentions these sciences. Mechanics was a mathematical science. Optics was a mathematical science. Astronomy was a mathematical science. And harmonics was a mathematical science. Pythagoras was famously the person who, or maybe some of his followers, who applied ratio theory to the study of music. So now, Aristotle, given that he wasn't a professional mathematician, he didn't actually contribute to most of these sciences himself. He could be accused of being ignorant of them, but he wasn't. In Physics, Book 2, Chapter 2. He talks about the differences between mathematical abstraction and abstraction in the natural sciences, which is very sophisticated and very clever. There's a person who I was on the dissertation committee of many years ago, Emily Katz, who's done some really terrific work on Aristotle's philosophy of mathematics, which I strongly recommend. And all of Book Mu and Book Nu of the Metaphysics, the last two books of the Metaphysics, deal with various approaches to first philosophy that people might take, other than the approach that he's been defending in the Metaphysics. And among those are mathematicizing Platonists and Pythagoreans. So he has a pretty sophisticated story to tell about how those sciences apply. Posterior Analytics 1, basically chapters 7 through 13 of the Posterior Analytics talk about what Aristotle refers to as subalternate sciences, where ordinarily you have sciences that are distinct from one another, are distinct in domain, if you like, as pure mathematics is from natural science. But you also have cases where there are facts discovered in one domain that are amenable to explanation by using the techniques of the other domain. And that's the case in these examples that I've given. You can't explain everything in meteorology using geometry, but there are certain facts that are amenable to that. Similarly with astronomy, you can't explain, what the stars are made out of or anything like that, but given that the motions are, Aristotle thought, as did most people in Greece, perfectly circular and are moving at a certain speed, a certain velocity, you can use various branches of geometry in application to astronomy. And famously, of course, that just gets developed better and better and better, culminating in the works of Ptolemy. And so it's pretty clear that Aristotle thinks that there are many ways in which the mathematical sciences intersect with natural science.
I think we have covered most of the essential questions. Maybe the last thing I wanted to touch upon is you speak about the relationship between education and methodos in Aristotle. I'd be very interested if you could expand on this.
Yeah, so the Greek word is paideia. It's very hard to translate because it's education is a common way of translating it. In fact, in my translation of the parts of animals, I translated it that way. But the better way to think about it, and this is what I use in Aristotle on Inquiry, the book, is as a sophisticated kind of what I call discernment or judgment. And Aristotle talks about it in an abstract philosophical way a number of times in the Politics, in the Nicomachean Ethics, in the Parts of Animals, the first two paragraphs of the Parts of Animals. And what he seems to have in mind is it comes at different levels. You can be just a generally discerning kind of person that has sort of, and I know people like this, no matter what area you're talking about, they seem to be able to ask the right kinds of questions and sort of skeptically, critically um, uh, pose questions to the person who's speaking. When I was the director of the Center for Philosophy of Science at Pitt, I gradually developed, even though there were speakers who were speaking in areas of science that I have only a very amateur understanding of, I gradually developed, probably by listening to other people that had the expertise in these areas, I gradually figured out that there are questions you can ask about somebody talking, say, on relativity theory that I know very little about. Um, Based on the presentation they've given, that doesn't depend on me knowing very much about relativity theory. It depends on me being able to see weaknesses in the way the argument unfolded and so on. And I think Aristotle sort of has that in mind, that it's this ability to be discerning and have the ability to judge, as he says, what's well said and what isn't well said in a particular area. But he also says that there's another kind of this discernment which is specific to a specific topic. And he talks about this at the beginning of the Parts of Animals, because he's going to be the first book of the Parts of Animals isn't really the first book of the Parts of Animals. The first book of the Parts of Animals is an introduction to the proper way to go about studying or investigating living things, especially animals. And he eventually says, and for the study of nature as well, we require to have certain standards by which we can judge whether an inquiry has been well carried out or not. And then he says, apart from whether it's true or false. So this isn't a judgment about whether what the person is saying is true or false. It's whether they've said it properly or whether they've investigated it properly. I mean, and then I think if you read the rest of book one of the Parts of Animals, that's what Aristotle's doing. He's giving his listeners, his students, standards by which to determine whether Empedocles was right when he explained the vertebrae in animals that have spinal columns that have vertebrae by saying that it just happened to get broken up during embryological development into pieces, or whether, in fact, there's a teleological explanation for why animals that have vertebrae have them. What's the good of having your backbone broken up into these segments the way they are? What's the value of that? So he can say whether Empedocles gets the facts right or not, it doesn't matter. He's got the explanation wrong. And that's the kind of thing that you get through the rest of book one of the Parts of Animals. It's these standards for judging other people's investigations, first of all. But of course, the same standards will be the standards you ought to adhere to in order to do things correctly and not get things wrong the way Empedocles or Democritus did. So I think that's the notion of paideia. And yeah, I think in practice, I think that's what goes on in a lot of science labs, the mentoring of graduate students and especially precocious undergraduate students in labs is the best people that do that kind of thing are the lab directors that walk around and ask the student, well, why did you do it that way? Did you consider doing it this way? Asking questions like that. That's, I think, a lab director practicing paideia, practicing the development, or I should say, practicing the development or encouraging the development of paideia in the students. So I think it's a distinction that's as relevant today as any time, I think.
I think it's very interesting to hear someone speak about getting proper education, getting proper experience in connection to method. Because today, many people in philosophy of science, but in epistemology too, don't have such kinds of norms in mind when they are speaking of providing normative guidance. Especially popular today is probability theory, where you have very formal, almost, or even completely algorithmic norms of how you ought to inquire, and that's something I think contrary to what Aristotle does.
Yeah, this whole idea of trying to reduce inductive reasoning to probabilistic confirmation theory, I think is, again, it's a result of things that were done by Carnap and Reichenbach back in the early 20th century, maybe going back even a little bit further than that. And as I say, I think it's a unfortunate detour off of discussions of induction that have been going on for 2,000 years, basically. And all you have to do is go back to the 19th century, and you'll see a very different understanding of inductive method.
Yes, maybe especially relevant was development of mathematics in the 19th century, because basically the concept of logic became suited for that kind of research, and then people were again trying to model inductive reasoning on the same kind of way of thinking.
Yeah. That's a complicated topic. The attempt to meld mathematics and logic, first sort of algebraic logic, and then let's try to do the same thing with induction. Well, how can we do that? Well, of course, since David Hume, we know that inductive results are only probabilistic. You can't be certain about your inductive conclusions. So maybe probability theory is the way to go.
Yes, that's why I was asking about education methods, because it runs against that idea that what logic is really about is about manipulating formal symbols, or that even providing guidance is about providing basically mathematical logic instead of such norms of inquiry as you discuss in the context of Aristotle. That's basically all I wanted to discuss today. It's been a great pleasure to have you join this interview.
I enjoyed it very much, Art. Very much.
I'm happy. I'm happy that this is so. I think besides more specialized topics, we have covered also those of more general interest. So both kinds of audiences will be satisfied.